The last type of ionic compound that we are going to discuss are what are referred to as ionic hydrates. So far, when we've been talking about ionic compounds, the type of compound that we have been discussing would be considered an anhydrous ionic compound. The term anhydrous indicates that there are no waters present. A hydrated ionic compound, though, is a compound that contains water as part of its crystalline structure, meaning that if we were to use X-ray diffraction, which is the most common technique for observing a crystalline structure, we would see individual water molecules that are present as part of the compound. Now, please do not confuse a hydrate with a wet ionic compound. When you're working with a hydrate, the number of waters that are present in the crystalline structure will always be a constant number of waters. That is very different than dealing with a wet compound. In a wet compound, the quantity of water does vary, and the water itself is not part of the crystalline structure. Now, in working with ionic hydrates, to name an ionic hydrate, it is actually quite a simple process. First, we're going to name the ionic compound as per the directions in the previous PowerPoint. What is different is we're going to indicate how many hydrates are present in that crystalline structure. We do so using a prefix system. If there is one water present, we call it a monohydrate. If there are two, dihydrate, three, trihydrate, and so on and so forth to 10, which is a decahydrate. So in naming a hydrate, we're going to name the ionic compound just as we have been previously naming the ionic compound. But after the name of the ionic compound, we're going to indicate how many waters are present using the prefix appropriate for that number of water, followed by the word hydrate. So for instance, this substance right here, barium is a metal of a constant charge. Therefore, to name this compound, it would be called barium chloride. But this is a hydrate, as indicated by the presence of water in this crystalline structure. To indicate that it has a hydrate, we'll use this dot to separate the ionic compound from the number of waters. This dot does not mean multiplication. It is simply how we write the formula for a hydrate. So again, this is barium chloride, and we have a hydrate. Specifically, we have two, which is dihydrate. So we would call this barium chloride dihydrate. This one is another common compound that you'll encounter. In fact, you'll encounter it when we do the hydrate lab, and that is copper sulfate. Again, we're going to name the ionic compound. Now, copper is a metal whose charge varies, so you had to use the formula to help figure out what the charge was. Once you figured out that charge, you would have found that it was a +2 charge, and so we would have indicated the charge on the copper as a Roman numeral in parentheses. So this is copper 2 sulfate. Now there are 5 waters in the formula as indicated by the 5 preceding the water. The prefix for 5 is penta, therefore this is a pentahydrate. So the entire name for this compound is copper 2 sulfate pentahydrate. So, differences between an anhydrous compound and a hydrate. Anhydrous, no water present. Hydrate, we indicate how many waters are present in the chemical crystalline structure, in the chemical formula, using this dot and the quantity. Copper sulfate anhydrous, copper sulfate pentahydrate. Again, we indicate a hydrate using the dot followed by the number of waters. This dot does not mean multiplication. I want you to understand that this dot does not mean multiplication. This is going to be extremely important when we talk about determining the molar mass for a hydrate, because when we figure out the molar mass for the hydrate, we're going to add up the mass for the copper sulfate alone. Then we're going to add to it the mass of 5 water molecules. So again, that dot does not mean multiplication. It is simply how we write the formula for a hydrate.